All right. In today's lesson, we are going to be solving systems of equations by graphing. In 1.1 and 1.2, we practice graphing single lines. In 1.3, we will be graphing two lines on one graph to find the solution for our equations. We'll begin with a warm-up just to keep our skills fresh. In number 1, we are multiplying a -8 and a -8. So our signs are the same when we're multiplying. That means we are going to get a positive answer. So when we're multiplying or dividing, if our signs are the same, our answer is positive. And then we do 8 times 8 to get 64. In number 2, our signs are different. When our signs are different, when we're multiplying or dividing, we will get a negative answer. And then we'll work out 3 times 6 to get 18. In number 3, we have a positive 10 and a negative 2. Our signs are different. When we're multiplying or dividing, different signs will give us a negative answer. 10 divided by 2 is 5. And in number 4, we have -24 and -6. Our signs are the same, which means our answer will be positive. 24 divided by 6 is 4. Let's take a moment to solve some 1- and 2-step equations. In our 1-step equations, we are getting b by itself, which means we need to get rid of this 6 that is adding to b. In order to undo a 6 that is adding, we will subtract 6. So we do the inverse or the opposite operation. Those go away so that b is by itself. And 2 minus 6, when we are adding or subtracting, if our signs are different, we will subtract. So 6 minus 2 is 4, and then keep the sign of the larger number. In number 6, we need to get x by itself, which means we need to get rid of this -4. We get rid of a -4 by doing the opposite or the inverse operation. We are going to add 4 to both sides. A -4 and a +4 cancel each other out so that we are left with x by itself. And then on this side, our signs are different, so we will subtract 4 minus 1 to get 3 and keep the sign of the larger number, which is positive. In number 7, we need to get m by itself. It is being divided by 2. The inverse operation of divided by is to multiply. So I'm going to get rid of divided by 2 by multiplying 2. And that makes those cancel out. A times 2 undoes a divided by 2. But what I do to one side, I have to do to the other. So on my left side, m is now by itself. On my right side, I'm going to work this out. I have a -4 and a +2. My signs are different. When we multiply, different signs means we get a negative answer. 4 times 2 is 8. In number 8, we have a -3 multiplying with n. Whenever we see a number directly next to a variable, it means that it is multiplying. So even though this is a -3, we could not add 3 to cancel these out because this is multiplication and we cannot cancel out multiplication with addition. We have to use division to cancel out multiplication. So I'm going to divide -3 to both sides. That makes these cancel each other out to create just a 1n. The other way that we can do this is we can just write it as a regular n. And now we can work out 6 divided by -3. It's a +6 and a -3, so our signs are different. which means we will get a negative answer, and 6 divided by 3 is 2. All right, a couple two-step equations, and then we'll get into the lesson. In this two-step equation, I need to get k by itself. In order to get k by itself, I'm going to need to move both the 4 and the 1. If you notice here, the 4 is attached to the k by multiplication. So I'm going to put a little times up there. I guess I'll use a little times dot. And then this 1 is a positive 1. It's adding to that. So I'm always going to take care of my adding or subtracting numbers before I take care of my multiplying or dividing numbers. So in order to get rid of a positive 1, I'm going to subtract 1 to both sides. That makes that cancel out. It becomes 0, right? 1 minus 1 is 0. And then I can rewrite 4k equals, and 29 minus 1 gives me 28. Now I can take care of my multiplication. The way I get rid of a 4 that is multiplying with k is to divide it. Those cancel out to give us 1k equals 28 divided by 4. That's how I read that. 28 divided by 4, which gives us 7. Okay. Number 10 is a multi-step equation. So I need to get x by itself, but there are some things happening before I can start working that out. And the first thing that I need to do is I need to distribute this 2 into my parenthesis group, so into my quantity 6 plus x. So 2 times 6 gives us 12, and 2 times x gives us a positive 2x. So I've distributed my 2 in. That's what gave me my red values there. 2 times 6 is 12. 2 times x is 2x. Now I have in purple multiplication here and addition here. So I'm going to take care of my addition number first. So I get rid of addition by subtracting. So I'm going to subtract 12 to both sides. 24 minus 12 will give us 12. And then 2x gets rewritten. So 2x equals 12. Now I can get rid of my 2 that was multiplying with x, and I get rid of it by dividing. X equals 6. 12 divided by 2 is 6. All right. We're going to go over the direction of the slope and the y-intercept just briefly. If we are given a problem like this, remember the main thing that we're working with or that we're using is slope-intercept form. Y equals mx plus b, where m is our slope. That's the number that sits next to x. And b, so I'm going to say m, and b, I'll do in blue, is the number that is adding at the end of our equation. So in this equation here, the number next to x, our m value, is 1. There is a 1 sitting next to this x because it is a 1x. So that is a 1x. Now, our b value, oh, that's not a highlighter. Our b value, there is no b value here. There are 0 b values. So b equals 0. So this is kind of the trickiest one when you see y equals x and you go, oh no, there's not enough information. There really is. That is y equals 1x, so that gives us our slope value of 1, or we can write it as 1 over 1. And if there's no b, we can say b equals 0. And then the direction here, it's positive, so it's going to go up, and we always go to the right. Let's take a look at number 12. We have our m equals 2 and I can write it as a fraction, 2 over 1, b equals negative 4. And then we're stating the direction. This is a positive 2, so it's going to go up. And then we always go right. So number 3, I'm going through these pretty quickly because videos 1.1 and 1.2, we spent a lot of time working on this. Another way we could label this, I could say m underneath, b underneath. So m equals 2 over 1, b equals negative 5. That's going to be up because it's positive, and we always move right. Okay, and then finally, m equals 1 over 4. It's positive, so we're going to go up and right. b equals 2. Okay, so one of the main hurdles to graphing is being able to identify the information. One of the other main hurdles is being able to identify the direction of the slope. If we can do those two things, then graphing is pretty easy. So for number 15, I can say that our m equals, I'm getting my number here, the number next to x, so 2 over 1, b equals 5. And then I can give my direction. This is positive, so it's going to go up and right. So when we're graphing, we always start or begin with our b value. So b tells us where to begin, so I'm going to begin at positive 5. My m tells me how to move. My m is telling me I need to move up 2 and right 1. So from that point, if I were to count up to, let's see, and I'm going to create a little person here. Smaller. Okay, there's my little person. And my person's sitting here at 5 where it began. And I need to count up 2 and right 1. Now the problem is my person ran out of graph. My person can't go up 2, right 1. There's just no room there. So instead, my person is allowed to go the exact opposite. So if I was going up, I'm going to go down, and if I was going right, I'm going to go left instead. So I can also use this value. So let's see, if my little person goes down to left 1, I get a point there. Down to left 1, I'll get another point there. So let me put some of these points in. Down to left 1. Another point there. I'm counting down to left 1. 1, 2, left 1. So my little person can keep going down to left 1, down to left 1, down to left 1. We'll use him later. Okay, and then that creates our line for us. It's really important to get used to writing multiple points on the graph because it's easier to see. Sometimes our lines get a little bit off, and even if they're just a little bit off, it can throw our answer off when we're graphing two lines. Okay, so m equals negative 2 over 1, b equals 4. Up until this point, everything is review. So we are going down to right 1. That was a negative 2, so we're moving down, and then we always go right. So take a look. Here's my little person, and he's going to begin at 4. So here he is at 4. I'll put a point there, and then we're going to move down 1, 2, right 1. Put a point there, down 2, right 1, point, down 2, right 1, down 2, right 1, down 2, right 1. Okay? So again, the idea is we begin at 4, it's our b value, and then we move down 1, 2, right 1, down 1, 2, right 1, down 1, 2, right 1, down and right, down and right. So if you can count, you can graph. There we go. If you can count, you can graph, and I can get rid of these lines. We put arrows at the end. Okay, very good. That's the whole point in graphing. Every point on the line is a solution. It's an x and y value solution to the equation. So 0, 4, if I plug that in for x and y, if I made x 0 and y 4, I would end up with a true statement when I solved it out. Same thing here. If I made x 1 and y 2 and plugged it in and solved it out, I would end up with a true statement. I might get something like 2 equals 2, or 4 equals 4, or 7 million equals 7 million, which are true statements. For numbers 17 through 20, and this is the new part of the lesson today, so all of that was review so that we can understand what we're doing here. With a single equation, there are multiple answers. So every point is an answer to our solution. When we have two lines, there is typically only one point that is our answer, that is our solution. So we are going to graph both of these lines. So I'm going to make this one purple. So I'm going to do a purple line. And I am going to do an orange line for my second one. So in purple, I'm going to have my m equals b equals. So for my purple equation, -1/4, which means I'm going down and right, and b equals, I'm going to move this just for a little bit of room, b equals -4. If you want to, you could just graph this line right away. So -4 is where we begin. I'm going to count down 1, right 4. Remember, I'm also allowed to do the exact opposite. So I can go up and left as well. I could go up 1, left 4, and put a point here as well. And that gives me my purple line. If you notice, my line's off a little bit. Try and fix it, which is part of the reason why it's so important to put a lot of points, because it's easy for our lines to get off. And then in orange, I have my, go away. I have my orange, m equals, and that's going to be 5/4. And I have my orange, b equals, and that's going to be 2. So for this one, I'm going to begin at 2, and I'm going to count up 5, right 4. So here's what happens. I count up 1, 2, 3, 4, 5, and over 4, and look at, my point's somewhere over here, but I'm off the graph. So instead of that, I'm going to do the exact opposite. So up and right didn't work. Instead, I'm going to go down and left. I didn't mean to scratch that out so soon, I think. So instead, I'm going to go down, because that's the opposite, and left, that's the opposite. So those ones didn't work. So now I can count down 1, 2, 3, 4, 5, left, 1, 2, 3, 4. And if you notice, my points overlap. My purple point overlaps with my orange point, and that's exactly what we want. So where these overlap is actually the solution. This is the common point between my purple and my orange, so this is my solution. So we will write our solution as an ordered pair, x, comma, y. So my x value to this point is -4. That's my x value. My y value for this point is -3. So that's my x and my y, -4, comma, -3. So we learned how to graph single lines so that we could graph 2 lines and find our solution to a system of equations. I liked using purple and orange, so I'm going to do that again. My top equation will be purple. Bottom equation will be orange. So I'm going to do 2 different sets. I'm going to say m equals 7/1. That's going to be up 7, right 1. B equals 4. So I'm going to begin at 4. And I cannot go up 7. There's no way. There's just not enough graph. So instead, I have to do the exact opposite. I'm going to go down and left. I got to do the exact opposite. So those are what I'm going to do, not these. So I'm going to count down 7. 1, 2, 3, 4, 5, 6, 7. Left 1, just 1. So down 7, left 1. That's the only place on the graph I have room to put that point. Again, my lines, I don't have a ruler. It's kind of hard to do on the iPad, so my lines might be a little bit off, but that's why the points are so important. So there's my purple. Here I'm going to do my orange. So m equals, now that is a, if it's just an x, there's a 1 sitting next to it. That is a 1x. The same way that you have, maybe one phone, like if you're like, hey, hand me my phone. You're not going to say, hand me my one phone, but that's exactly what you mean, just the one phone. So b equals -2. So we're going to begin at -2 and move. So 1, I have to make that a fraction, and we're going up and right. Up because it's positive, right because we always go right first. So there's 1 there. Up and right, up 1, right 1, up 1, right 1, up 1, right 1. So even though I did all that work, my points don't overlap. But what can I do? Well, I could also do the exact opposite, right? So I can go down and left, which means if I go down 1, left 1, oh, there we go. Down 1, left 1, my points overlap. So this is my solution right here. And so we're going to write an ordered pair. I'll do that in blue. My x value, comma, my y value. So for my x value, which is on my x-axis, is -1. So -1. And my y value, which is on my y-axis, is -3, right? If I go here, -3. And those are the coordinates. Okay, 2 more. These will be a little bit less talked through and just more solved out. Organizing my work, which is very important. So let's see, we have purple. And in purple, ooh, my handwriting fell apart. M equals, which means it's going to be down and right. In orange, which is going to be up and right. So I can do my purple and then my orange. So I'm going to graph purple. B equals -4. So I have to begin at -4. And then I'm counting down 2, right 1. 1, 2, oh no, I've run out of graph. Okay. So when that happens, remember we do the exact opposite. We can go up and left. So the opposite of down and right is up and left. So now I can count up. 1, 2, left 1. 1, 2, left 1. I'm going to do points all the way across the graph. As many points as I can do on the graph. So there they all are. and that I could make a line over it. Okay, and then for my orange, begin at 3, and I'm counting up 1, right 3, put a point, up 1, right 3, I end up off the graph, so that's somewhere out there. I can also do the exact opposite, so I could count down and left, which means I go down 1, left 3, and there's our point right there. So the place where our lines overlap is our answer. That's our solution. Show us in red. So our solution, which we will write as an ordered pair, x, comma, y. So my x value is at -3. So at -3, that's our x value. And our y value is 2. Oh, I wrote -x for whatever reason. -3. -3, comma 2. All right, last one. I'm not going to talk at all during this one. I'm just going to solve it. What you can do is talk through to yourself. Tell yourself as if, what would my voice be saying? What would I be saying? Okay? So tell yourself as you're watching this happen. And that's our solution, 3, comma, -1. We'll be working on this next couple classes, but hopefully this was clear enough. I know there's, looking at it, the colors seem crazy, but if you see the process, you'll get more and more familiar with it.